Welcome to my presentation. In this presentation, let us try to solve examples of the form ax plus b is equal to cx plus d. So let's say we have an example where we want to solve for x. In here, the example is as follows: 3 open brackets, 2 minus 4 open parentheses, 2x minus 1 close parentheses, close brackets is equal to 4x minus 10. Let's say we have a problem like that. In here, let me write this step number 1. We want to be able to simplify these types of equations using the order of operations. The order of operations we've been talking about is the PEMDAS process, PEMDAS. Wherever we have terms inside the parentheses, we'll simplify them. Then we will expand the exponents if we have any. Then we will perform the multiplication, division, addition and subtraction as they occur from left of the equation to the right of the equation. So therefore, we will start this simplification process and see how far we can go, and then we will use the addition, subtraction, multiplication, division rules to solve for x. So 3 open brackets, 2 minus negative 4 times 2x is negative 8x, negative 4 times negative 1 is positive 4, close brackets. So we simplified the terms inside the parentheses by distributing the negative 4 to every one of those terms, is equal to 4x minus 10. We can simplify some more the terms inside the brackets. So we have some similar terms there. 3 times 2 plus 4 is 6 minus 8x is equal to 4x minus 10. Now we are ready to distribute the 3 to every one of the terms inside this set of brackets here. So therefore 3 times 6 is 18 minus 8 times 3 is 24x is equal to 4x minus 10. So now we are ready to use the properties addition, subtraction, multiplication, division, and isolate the x value to one side of the equation so we can find its value. So to achieve that, let's go to the second step, and then it is our choice. Either we can eliminate the x term first or eliminate the constant term first, or we can eliminate both in one shot, but I want to break it into two different steps so you see the process happening. So let us say we want to get rid of the 18 on the left hand side. Okay, we're going to add negative 18 to both sides of the equation, and when we do that, what is going to happen? Negative 18 is what we have added, plus 18 minus 24 is equal to 4x minus 10 minus 18. I put those numbers what we have introduced in red and also circle them so that we see what is happening. Okay, then the negative 18 and positive 18 cancels out, leaving us with negative 24 on the left hand side is equal to 4x minus 28. So negative 10 plus negative 18 is negative 28. We have constant numbers on both sides of the equation, so therefore we want to get rid of the 28 on the right hand side. Therefore we will write this next step, step number 3. We're going to add positive 28 to both sides of the equation, and when we do that, this is what we're going to achieve. So plus 28 on the right hand side minus 24 is equal to 4x minus 28 plus 28. Okay, so the positive 28 and negative 28 cancels out on the right hand side, leaving us with 4x is equal to 28 minus 24 is going to be equal to 4. And since we have boiled it down into that equation now, we want to find the value of 1x. We don't want the value of 4x. So therefore, we'll do one more step to get that value. Since we have 4x is equal to 4, we want to get the value of 1. We're going to take the value 4 and multiply by its reciprocal. The reciprocal of 4 is 1 over 4. And we know that when we multiply a number by its reciprocal, the product is always going to be equal to 1. So therefore, we're going to multiply by 1 over 4 on both sides. And therefore, how do we get that? 4 times 1 over 4, like that, is equal to 4x times 1 over 4, like that. So the 4 in the numerator, 4 in the denominator cancels out, leaving us with x equals to 4 in the numerator, 4 in the denominator cancels out, leaving us with 1. So therefore the value of x is equal to 1. That is what we have arrived at. This is the way we want to be able to solve these types of linear equations using the addition property, using the multiplication property. This example is telling us that we may have to use these properties several times in this process to be able to arrive at the final solution. Now that we have arrived at the solution, we should be able to check our work. In this next step, we will show you how to check the work. The given problem is this. The given equation is 3 times 2 minus 4 times 2x minus 1 is equal to 4x minus 10. If this is the problem we have, when x equals to 1, the value what we've obtained on the left hand side should equal the value what we obtain on the right hand side. So let us see if we can get that. 3 times 2 minus 4 times 2 times 1 minus 1 is equal to 4 times 1 minus 10. So let's simplify this. So 3 times 2 minus 4 times 2 times 1 is 2. 2 minus 1 is 1, right? Is equal to 4 times 1 is 4 minus 10. So in here, 3 times 2 minus 4 times 1 is 4. 2 minus 4 is negative 2 is equal to, when we simplify this, that becomes negative 6. On the left hand side now, 3 times negative 2 is negative 6. That value is exactly equal to what we have on the right hand side. Negative 6 is equal to negative 6. Therefore, we can conclude that the value of x equals to 1, what we have arrived at, is exactly correct. Right? So this is the way we want to solve linear equations of the form ax plus b is equal to cx plus d by using this addition, subtraction, multiplication and division rules. In my next presentation, we shall look at some more examples to see how we can solve linear equations of the form ax plus b is equal to cx plus d.